Assalamu alaikum dear students. In previous video lecture we discussed how to find distance between the point and the given line and distance between two parallel lines. Now today we are going to discuss a few examples of exercise 10.3. Now question number 4 of this exercise is find the distance of the point -1 1 from the line 12x plus 6 equals to 5y minus 2. Now here given line is 12x plus 6 equals to 5 into y minus 2. So firstly convert or write this form in general form, that is when we multiplying on both sides we simply get 12x plus 72 equals to 5y minus 10, or 12x minus 5y plus 82 equals to 0, and this is 0. So this is the equation in general form and it represents the straight line. Now we have to find the distance of point -1 1 from this line. On comparing this line with the general form, which is ax plus by plus c, we get a equals to 12, b equals to -5, c equals to 82. Since we have already proved that the distance between the point x1 y1 from the line ax plus by plus c equals to 0 is given by d, which is modulus of ax1 plus by1 plus c upon root of a square plus b square. Here the point is -1 1, which implies that x1 is -1, y1 is 1. So when we put these values, that is a is 12, b is -5, c is 82, x1 is -1, y1 is 1 in this d, we simply get d equals to modulus of 12 into -1 minus 5 into 1 plus 82 upon square root of 12 square plus -5 square. So after adding and subtracting we simply get 65 upon 13, which is d units. Hence distance of this point -1 1 from this line given line is 5 units. Now question number 5 is find the points on x-axis whose distance from the line x upon 3 plus y upon 4 equals to 1 or 4 units. So we have to find those points on x-axis which are at a distance of 4 units from this line. Now the given line is in intercept form, so firstly convert this form into general form. So by cross multiplication we get 4x plus 3y equals to 12, or 4x plus 3y minus 12 equals to 12 equals to 0. Now any point on x-axis is of the form of x1 comma 0, because y coordinate is here absent, means y coordinate is 0, which implies that points on x-axis are of the form of x1 0. Now by given condition, distance of these points from the given line is 4, which implies that when we substitute the value of x1 equals to x1, y1 equals to 0 in this formula of d, that is distance, we simply get 4x1 plus 3 into 0 minus 12 upon under root of 4 square plus 3 square, which is simply modulus of 4x1 minus 12 upon 5. Here d is given to be 4, which implies that modulus of 4x1 minus 12 equals to 20. Now you know that this modulus of x is defined as x if x is positive and is negative x if x is negative. Now here this 4x minus 1 minus 12 is the variable, so it can be either positive or negative. If it is positive, if 4x1 minus 12 is greater than 0, which implies that 4x1 minus 12 is here 20, or if it is negative, then it is minus 4 times 4x1 minus 12 equals to 0. Or in first case when it is positive, x1 is 8. In second case when it is 9, by multiplication x1 is minus 2. So this means that the points x1 0 is 8 0 or minus 2 0 are the only two points which are at a distance of 4 units from this line x by 3 plus y by 4 equals to 1. Now question number 6 is find the distance between the two parallel lines 15x plus 8y minus 34 equals to 0 and 15x plus 8y plus 31 equals to 0. Here lines should be parallel. If they are non-parallel lines, means they are intersecting either at one point or at infinitely many points, which implies that at that time distance between these two lines is 0. So if we have to find the non-zero distance, then lines should be parallel. For parallel lines in general form, coefficient of A and coefficient of B should be same, because when they are same implies that the slopes are equal. When slopes are equal implies that these two lines are parallel. That is why here the coefficient of x in as well as in y in both equations are same, because the lines are parallel. And we know that the parallel lines are of the form of general form or ax plus by plus c1 equals to 0, ax plus by plus c2 equals to 0. And the distance between these two parallel lines is given by d equals to c1 minus c2 upon a root of a square plus b square. Here a is, on comparing, c1 is minus 34, c2 is 31, a is 15, b is 8. So on substituting in this equation we simply get d equals to 65 upon 17. So the distance between these two parallel line is 16 upon 65 upon 17 units. Now question number 8. Find the equation of line perpendicular to this line x minus 7y plus 5 equals to 0 and having intercept x intercept equals to 3, that is, and having x intercept 3. This means that this line, which is perpendicular to x minus 7 plus 5y, cuts the x-axis at a distance of 3 units from the origin on the positive side of x-axis. Here given line is this, so converting it into slope-intercept form, we simply get y equals to 1 upon 7x plus 5 upon 7. So which on comparing with y equals to mx plus c, slope of this line, that is x minus 7y plus 5, is 1 upon 7. Now the line which is perpendicular to this line, the slope of the required line is given by minus 1 upon 7, because by the condition of perpendicularity, which is simply 7. So the slope of required line is minus 7. Also it makes an intercept 3 on x-axis. Now any point on x-axis is of the form of x comma 0. So this means that this perpendicular line passes through point 30, that is, it passes through 30. Now we have a point through which a line passes, and we know it is slope. Now using the slope point form, y minus y naught equals to m times x minus x naught. Here x naught is 3, y naught is 0, m is minus 7. So on substituting in this we simply get 7x plus y equals to 20. So this is the required equation of line which is perpendicular to given line, that is x minus 7y plus 5 equals to 0, cutting x-axis at 3 units from origin, or having x-intercept equals to 3 units. Now find the angle between the two general forms of line, that is root 3x plus y equals to 1 and x plus root 3y equals to 1. You know that we find the angle between the two lines in terms of slopes. So firstly convert these two lines into slope-intercept form, or find the slopes from these two lines. So we simply convert these two lines into in the form of y equals to mx plus c. This means that slope of first line is minus root 3, slope of second line is minus 1 upon root 3. If theta is the acute angle between the two lines, then tan theta is given by modulus of m1 minus m2 upon 1 plus m1 m2, which is simply 1 by root 3, which implies that tan of theta is 1 by root 3. Hence theta equals 30 degree, because tan 30 degree is 1 by root 3. So this means that the acute angle between these two lines is 30 degree. Now here this is line L1, this is line L2. When they intersect at point, they form two pair of vertically opposite angles. Now one pair is acute, second one is obtuse. This means that this obtuse angle is simply given by subtracting 180, this subtracting 30, or this acute angle from 180, which implies that obtuse angle is 150 degree, because when they intersect we get two pair of vertically opposite angles. One is 30-30, second pair is 150-150. So this is the required angle between these two lines. So thank you.